Hi, Algebra 2. Okay, I want to finish that problem in first hour that we did not finish. I want to talk through it, and then I want to do a couple more problems so that you can finish this worksheet. And then I want you to work on the worksheet that is on my desk for you that says Algebra 2, solve equations with logarithms, or there might be one that says practice number 3. So there'll be some worksheets for you to work on. You also have a Delta Math, but we'll get into that in just a minute. Okay, so the problem that we were working on was this problem right here. So the first thing that we did was here we go. We added plus 8 to both sides because we want our form when we're solving exponentials. We want to be the base raised to some power equals a number. That's the form we want, and that is not what we have because we want to get everything away from our unknown right there. So that's why we added 8 to both sides. So then we end up with 8 times 10 to the 7q minus 6 equals 67. Okay, so we have that. And what we want to do now, and so I had a question that says, why can't we distribute that? And that's because we don't know how many tens we have, right? So if this were 10 squared, we would do 8 times 100. But if it was 10 to the 4th, we would have to do 8 times 10,000. So it's, we don't know how many base 10s we have, but we've got some good news. We can get rid of that 8 and we're going to divide by 8. And since I'm not letting you use a calculator, we're just going to leave this fraction 67 over 8. So now we have a base raised to some power that we don't know equals a number, which is exactly what we want. Now we have this form. Now it looks ugly, but we do have that form. So now what we're going to do is now we can do, so the first step to solving exponentials is we want to log or natural log both sides. Now remember, other sides, here we go. It's zooming in and I don't know how to stop it. Let me see if I can get this to work. Okay, so all my stuff went away, but we were down to 10 to the 7q minus 6 equals 67 over 8. So I was saying we need to log or natural log both sides. Now remember, we only use natural log when we have e in our problem. 2, then we apply the power property. So power property. Okay, so here we have to log both sides. So I'm going to take the log of 10 to the 7q minus 6 equals log of 67 over 8. Okay, so now I can apply the power property, and I like to keep this in parentheses. But this problem gets a little bit easier. So we have 7q minus 6 times log of 10 equals log of 67 over 8. So here's what we have. So we know that the natural log of equals 1. Whoops, equals 1. See if I can erase that. Sorry, I wrote the wrong number. Equals 1. See if I can. Nope, I can't get out of this. Dang it. There we go. Look at me learn things, guys. Okay, this equals, and I have to erase, equals E, does not equal E, it equals 1. Okay? But we also know that log of 10 equals 1 for the same reason. And look at this. I have a log 10. So I have a 1 right there. Because this one would be 10 to some power equals 10. Well, then that has to be 1. These two things say that. So if that's a 1, now my problem is so much easier. So now I'm going to get 7q minus 6 equals log 67 over 8. And now this is so much easier. Now I just have 7 times a number minus a number. Now I just need to isolate my variables. So I'm going to add 6 to both sides. And so then I'm going to write down here 7q equals log 67 over 8 plus 6. And then I need to divide both sides, the whole thing, by 7. So then I get Q equals log of 67 over 8 plus 6, all of that, whoa, stop, all of that over 7. Okay? And then that's our final answer. So about um, the nice thing about me not expecting your work or not letting you use a calculator on the test is you guys are going to be expected to show me your work. So if you need that answer, just go back a few seconds and you should be able to see it. Okay, so now we're going to go, let's see if I can get this to go to the next slide. Come on. There we go. All right, so now we're going to work on these. These are on the back side of that worksheet I gave out yesterday. So to do this one, we always want, when we're solving logarithms, we always want to use the inverse. So when we are using the inverse of a logarithm, we're going to write it as an exponential, and when we're using the when we're rewriting an exponential, we use logarithms. So we're always going to use the inverse of it. So what we're going to do here is we have 1 log of a base of a number equals a number, which is exactly what we want. So just like the exponentials, we want a log of some base equals a number of a number equals a power. That's what we want. And this is the form that we have. I could rewrite this as 2 to the third equals 4u. Now, I don't know what u is, but I'm going to be able to find it because I know what 2 to the third is. That's 8. I look up at my wall and I can see it. So we get 4u, divide by 4, divide by 4, and I get that 2 equals u. And that's my final answer. That's it. Now this one's a little bit trickier, but we know that natural log equals log base e, so I know what my base is, so I get e to the 5th equals 5v plus 7. Now this one's a lot harder to do without a calculator because e is a number, so we're just going to leave it as e to the 5th and not do anything with it. We're just going to leave it whole like that. So we're going to get e to the 5th. I'm sorry, now we want to isolate our variable because e to the 5th isn't an easy number. Again, if this were the part of the test, then I would just leave it as part of the test where you could use a calculator, but we're not going to. So we're going to leave it as e to the 5th, so we want to subtract 7 from both sides. And I get e to the 5th minus 7 equals 5v, and then I want to divide by 5, divide by 5, and then I get v is equal to e to the 5th minus 7, all of that over 5. That's it. Now, just like before when we were doing our exponentials, we want to make sure that we isolate because we want it to be log of some base of a number equals a power. Right now we have this 8 here. This 8's bothering me, so we need to add 8 to both sides. That says plus. And excuse me. So we get log base 4 of 6w plus 4 equals negative 5 plus 8 is 3. And now I can do this. I get 4 to the third equals 6w plus 4. That's a really weird W, but just trust me, it's a W. Okay, now I get that, and then I'm going to do it over here. So then I get 64 equals 6W plus 4. I'm going to subtract 4 on both sides. That says minus 4. You just can't tell. And then I end up with 60 equals 6W. Divide both sides by 6. And I get W is equal to 10. And that's my final answer. Okay, you guys should now be able to completely complete the worksheet that I gave out. You guys should be able to complete the Delta Math that is posted for you, and you'll be able to move on to the next worksheet. So that's what you have to work on Friday and Monday. And then I will be back on Tuesday to show you the rest of the stuff that we're learning. I hope you all have a great day. Have a good weekend. Be safe, be healthy, and don't do anything illegal. Bye. Have a great time.